this is Calculus 2, Math 160. 7.2, we're going to calculate the volume and we're going to use the disk method. Let's take a look at the picture here. Volume of the disk method is the area of the disk. As you can see, the area of the disk is circle. So the area of the disk will be pi r square times width. The width of the disk here is W, or delta x, because we have axis if axis of revolution is on the x-axis. Now let's look at the second picture. Volume is pi, and because we find the area of the disk, we can take an integral, and it's rotate about x-axis. So our integral is from a to b r square, and the thickness here is dx, or delta x. For the disk method, the representative rectangular is always perpendicular to the axis of revolution. As you can see here, we have a vertical axis of revolution, so it's perpendicular to our x-axis. However, if you have a horizontal axis of revolution, it's gonna perpendicular to the y-axis, and the formula for the volume will be pi, an integral from c to d, because we rotate about the y-axis. So from c to d, r is the radius. So the radius here is the distance from the y to the graph. As you can see, at the beginning it's short, and then it's getting longer and longer and longer here, dy. Same thing, this is the radius. The radius is from the distance from here to upper here. So that's the radius. Now let's take a look at one example. All right, write and evaluate the definite integral that represent the volume of the solid formed by revolving the region about the y-axis. So this is the horizontal axis of revolution. You have horizontal here is perpendicular to the y-axis. Our function is y equal x to the 2/3, and because it's horizontal axis of revolution, the formula is pi cd r square dy. Because we take an integral with respect to y, we're going to solve for x here. I have y equal to x to the 2/3. I'm going to raise both sides to the 3/2 to have x by itself. Then I have x equal to y to the 3/2. As you can see, my graph here is x equal to y to the 3/2. Now this is the rotate around the y-axis. So let's take a look at the three-dimensional. All right, if you look at the three-dimensional here, this is the graph that I just draw, right? And let's move this. So if you want to find the volume of three-dimensional, you're going to have a graph look like this. Now let's rotate it a little bit so you can see the whole picture on every angle. So this is the volume, right? The volume from different angle as I move here, and the three-dimensional. So we want to find the volume of this. All right, let's go back to our example. So the formula is v equal to pi and integral c to d r square dy. I'm gonna rewrite this. Pi is pi. You have an integral here. My c is 0 at this point, 0. My d is 1. And my radius is the distance from y-axis to the graph. So it changed from here is smaller, bigger, 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 and this is the longest one. This the radius is the distance from y to the graph, or the strip, the red one here. So I already solved my function x is equal to y to the 3 over 2. So I'm going to put y raised to the 3 over 2. This is my radius square dy. Again, the reason I solve for y, because we take an integral with respect to y. Let's simplify this a little bit. I would have pi, an integral from 0 to 1, y to the 3 over 2 squared. The 2 will cancel out, so you have y to the cube dy. Now if I take an integral of this, I'm going to have pi, y to the 4th over 4. The lower bound is 0 and the upper bound is 1. Then I will have pi, substitute 1 for y, I would have 1 over 4, substitute 0 for y, I would have 0. So the volume of this function is pi over 4. So that is the answer. Alright, so we will see more example in the class, and the next section that we will cover is the Watcher method, which is still 7.2. So I will see you next lecture.